Welcome! You'll now learn about Amazon Route 53. ELB and Amazon EC2 autoscaling enable you to achieve highly flexible, scalable, and resilient architectural designs. But what if you want to distribute traffic across AWS regions? There are several reasons why you might choose to do this. For example, you might distribute traffic to help prevent downtime when there are outages within a region. Or you might distribute content to reduce latency by providing the actual services closer to where the users are located. Amazon Route 53 is a highly available and scalable cloud DNS service. It's designed to be reliable and cost-effective as a means to route end users to internet applications. In its simplest form, it translates URLs like www.example.com into the actual numeric IP addresses that computers use to talk to each other, for example, 192.0.2.1. Route 53 connects user requests to infrastructure that is running in AWS, which could be EC2 instances, load balancers, or S3 buckets. And it doesn't have to always point to AWS resources. It can also be used to route to infrastructure outside of AWS. You can also use Route 53 to configure DNS health checks so it can route traffic to healthy endpoints if a health check fails. It makes it possible for you to manage traffic globally through several routing types, including latency-based routing, geo-proximity or geolocation-based routing, and weighted round-robin. You can combine these routing types with DNS failover to enable low-latency, fault-tolerant architectures. You can register domain names that you already own with Route 53, and you can configure DNS settings. In previous sessions, we covered ELB load balancers and how they distribute workloads across multiple compute resources, like virtual servers. Generally, the use of a load balancer increases the availability and fault tolerance of your applications because the load is spread over resources in multiple availability zones. When you create a load balancer, it is given a default DNS name, like the example here, and you can choose to use the default DNS name. But you might prefer to associate your own DNS name, which you could manage by using Route 53. For instance, you could register a domain name like example.com for your website or web application. Then, traffic is routed by Route 53 to your load balancer. A CNAME record can redirect DNS queries to any DNS record. For example, you could create a CNAME record that redirects queries from apex.example.com to acme.example.com or to acme.example.org. AWS also has something called an alias record, which works specifically to redirect queries to selected AWS resources such as S3 buckets, Amazon CloudFront distributions, or another record in the Route 53 hosted zone where you created the alias. Note that Amazon Route 53 supports 7 different routing policies. First, there's the simple routing policy. You use this for a single resource that performs a given function for your domain. For instance, a web server that serves content for the example.com website. Next, you can have a weighted routing policy. You can use this to route traffic to multiple resources in proportions that you specify. You can also use a latency routing policy, which routes traffic to the region that provides the lowest latency. To set up active-passive failover, you can use a failover routing policy. You can also use a geolocation routing policy, which routes traffic based on the location of your users. A geo-proximity routing policy routes traffic based on the location of your resources, and it can also optionally shift traffic from resources in one location to resources in another location. And finally, you can set up a multi-value answer routing policy, which causes Route 53 to respond to DNS queries with up to 8 healthy records selected at random. There's more information available about routing policies, and if you want to learn more, search for routing policy in the AWS documentation. Assume that you want to distribute your deployment architecture across several regions around the world so you can provide users with the fastest response time. Often, but not always, the region that's geographically closest to the user will give the fastest response time. For these situations, you can use Route 53 to perform latency-based routing, or LBR. And LBR enables you to use DNS to route requests to the AWS region that will give your users the fastest response. Take this example. Assume that you have load balancers in the US West Oregon region and in the Asia Pacific Sydney region. You created a latency resource record set in Route 53 for each load balancer. A user in Barcelona, Spain enters the name of your domain in a browser. DNS then routes the request to a Route 53 name server. Route 53 refers to its data on latency between the two regions and routes the request appropriately. In most cases, that would mean that your request is routed to the nearest geographical location, Australia for a user in New Zealand or Oregon for a user in Canada. A blue-green deployment refers to a deployment where you reduce the risk of the site or application becoming unavailable by running two matching production environments. One of these environments is referred to as the blue environment, and the other environment is referred to as the green environment. This diagram is an example of this kind of blue-green deployment. Notice that there are two parallel environments. Each has its own load balancer and automatic scaling configuration. And Route 53 weighted routing is used to begin shifting users over from the existing or blue environment to the new green environment. You might use this process to migrate users to the new upgraded green environment, for example. Technologies like Amazon CloudWatch and Amazon CloudWatch Logs can be used to monitor the green environment. And if you find problems in the new environment, you could deploy Route 53 weighted routing to shift users back to the blue servers. And when you're sure the new green environment is fully up and running without issues, you could gradually shut down the blue environment. Though be aware that because of the potential latency of DNS records, a full shutdown of the blue environment could take anywhere from a day to a week. It's always a good idea to test your scalability deployments by using load testing to simulate traffic. As a SysOps professional, you want some assurance that the scalability in the design performs as you expect it to. It's always better to discover issues before the deployment goes into production, so you can use as many open source tools to simulate load testing, including but not limited to the ones listed here. Thanks for watching, and see you in the next video.
Hello, and welcome to this video tutorial on Amazon Route 53 routing options. In this demo, I'm going to show you how to accomplish some different types of routing using Route 53. Specifically, I'll demonstrate simple routing, failover routing, and geolocation routing. And for each example, I'll first briefly show a diagram illustrating what I'm going to configure, and then I'll show you how to configure it in the AWS Management Console. And finally, I'll run a quick test in the browser to demonstrate the resulting routing behavior. Okay, let's get started. In this example, I have a registered internet domain named mompopcafe.net that I'm managing with Amazon Route 53. I also have a VPC with two Amazon EC2 instances running in it. Each instance is running a web server with my Mom Pop Cafe website hosted on it. The instances are configured identically, and I want to configure Route 53 so that HTTP requests are distributed evenly in a simple round-robin fashion between these two EC2 instances. To configure this, I'll need to define a Route 53 record set in the mompopcafe.net hosted zone. Now let's take a look at how this setup can be accomplished in the Amazon Management Console. Okay, so here I have three browser tabs all open to different views in the AWS Management Console, just to make it easier to show what already exists and is configured in this account. Here in the VPC area, you see public subnets 1 and 2 already exist. They are defined in different availability zones. And here in the EC2 area, you see that two instances of the Mom Pop Cafe server are running, one in each of these subnets, and you can see that they are in different availability zones. Let's just verify that one of these web servers is working and the website is available. I'll just copy the public IP address of the server 1 instance and paste it into another browser tab. I'll add Mom Pop Cafe to the end of the domain name since that is where my web app is running. And here you see the web app is running, which is great. However, keep in mind the objective here. I want end users to be able to find this web page by going to my domain. And not only that, I want to route traffic evenly between this instance and the other one. Notice on this page that it conveniently shows the availability zone of this server, in this case EU West 2A. The other server runs in EU West 2B. I'll need to copy the public IP address of each instance when I configure the Route 53 record set, so I'll leave this view open. Now over here in the Route 53 service dashboard, you can see that I have one registered domain and one hosted zone. If I click on registered domains, you can see that the domain named mompopcafe.net is registered with Route 53. You can find unclaimed domain names and purchase and register them through the AWS Management Console, or you can also transfer a domain purchased through another vendor over to Route 53 for management. Once your domain is registered in Route 53, if you click into Hosted Zones, you will see a hosted zone has been created with your domain name. Clicking into the hosted zone, you see that 2 record sets already exist because they were created when the domain was registered with Route 53. The NS, or name server record, lists the 4 name servers that are the authorized or authoritative name servers for your hosted zone. You should not add, change, or delete name servers from this record. The start of authority, or SOA record, identifies the base DNS information about the domain. It was also created when the domain was registered with Route 53. But now I need to create a new record to configure the simple routing. So I click Create Record Set, and then I'll give it the name www.mompopcafe.net, and this will add a type A record, which will simply map the DNS name to 1 or more IP addresses. The time to live, TTL, will be the number of seconds that DNS resolvers should cache information about this record. For the purposes of this demo, I'll make it very short, 15 seconds. Now the value is where I need to paste the public IP addresses of the 2 running servers. So I'll go back to the EC2 page here and copy the first one, and then return to the Route 53 page and paste it in there. And now I'll copy the second one as well and paste that in as well. And now we get to the routing policy. From the drop-down menu, I'll choose Simple, which happens to be the default, and that's it. Click Create to save the record set. Now let's test this configuration. I'll open a new browser tab and load the URL www.mompopcafe.net/mompopcafe. And here we see one of the 2 instances page loads. In this case, it's EU West 2A. And now I'll load the page a few more times, and you'll see that the same URL takes me to one of the 2 instances. Since I specified multiple values in the record, in this case 2 IP address values, Route 53 returns these 2 values to the recursive resolver in random order, and the resolver returns the values to my web browser that submitted the DNS query. So as you see, HTTP requests to my domain name are being routed between the 2 instances I specified in the record set. This concludes the simple routing part of the demo. In this failover routing example, I have a registered internet domain named mompopcafe.net, and I'm managing it with Amazon Route 53. Just as in the last demo, I have a VPC with 2 subnets in it. The subnets are in different availability zones, and each subnet has an EC2 instance running in it. And each instance is running a web server with my Mom and Pop Cafe website hosted on it. The instances are configured identically, and I want to configure Amazon Route 53 so that one of these instances, the one in availability zone 1, is the primary server that will service all HTTP requests. However, if the primary goes down for any reason, I want the instance running in availability zone 2 to take over the handling of the HTTP requests so that users won't even notice that my primary web server went down. So how can I configure this? I'll first need to define a Route 53 health check that monitors the status of the primary web server instance. If the health check determines that the primary instance is unreachable, then the record set I define in the mompopcafe.net hosted zone will route traffic to the second instance instead. The Route 53 health check will also send an alert to my administrator team to inform us about the unreachable instance. So now that we understand the design, let's take a look at how this setup can be accomplished in the AWS Management Console. Okay, so here we have, again, 3 browsers all open to different views in the AWS Management Console, just to make it easier to show what already exists and what is configured in this account. Here in the VPC area, you see public subnets 1 and 2 already exist. And here in the EC2 area, you see that 2 instances of the Mom Pop Cafe server are running, 1 in each of these subnets. And you can see that they are in different availability zones. Let's verify that the primary web server is working and the website is available. So I'll copy the public IP address of the server 1 instance and paste it into another browser tab. And I'll add Mom Pop Cafe to the end of the domain name, since that's where my web app is running. And here you see the web app is running. Notice on this page that it shows the availability zone of this server. The primary runs in EU West 2A, and the backup web server runs in EU West 2B. I'll need to copy the public IP address of each instance when I configure the Route 53 record sets. So I'll leave this view open. Now over here in the Route 53 service dashboard, you can see that I have one registered domain and one hosted zone. If I click on registered domains, you can see that the domain named mompopcafe.net is registered with Route 53. And if I click into the hosted zones and then click on the mompopcafe.net hosted zone, you see that two records sets already exist because they were created when the domain was registered with Route 53. As in the last demo, I'll leave the NS and SOA records alone. The first thing I want to do is define a health check. So I go to Health Checks and click Create Health Check. I'll name it London Website Status. What to monitor is an endpoint, and I'll specify the endpoint by IP address. So I'll need to paste in the public IP of the primary web server running in EUS2A. I'll just go back over to the EC2 page view and copy that value, and then return to the Route 53 page and paste that in here. The port number is 80, the standard HTTP port. And for the path, I'll add mompopcafe since that is the URL that loads the web application. Let's expand the advanced configuration area, and since this is a demo, I'll set the request interval to a short period of 10 seconds. I'll also set the failure threshold, which is the number of health checks that need to fail before the health check status turns unhealthy. I'll set that to 2. And I'll leave the other settings as they are and click Next. And finally, create alarm, yes. So now we go down to the notification configuration screen, and I'll define an SNS topic, website down. And I'll enter my email address. Finally, I click Create Health Check, and there you see that the health check is now defined. It will initially have a status of unknown. However, this should be resolved within a few seconds. If I click Refresh, let's see if the status is updated. Yes, there it is now healthy, which means the health check has verified that it can hit the URL that I defined in the settings, and the web server is responding with an HTTP status code of 200. One quick thing to do at this point is to check your email and look for the subscription confirmation email you should receive. Click on the Confirm Subscription link in it, which should open a browser page indicating that your subscription is confirmed. Okay, so now that I have a health check configured, let's move on to configuring the failover routing that will be triggered whenever the health check returns an unhealthy status. I click over to Hosted Zones and then click on the registered domain. And now I'll click Create Record Set. I'll make the time to live very short, 15 seconds, and now the value is where I need to go back to EC2 page and copy that public IP address from the primary server. And now we get to the routing policy. So from the drop-down menu, I'll choose Failover. The failover record type is primary, since this is the IP of the primary server. Is this associated with a health check? Definitely. So I choose yes, and then from the drop-down menu, choose the health check I just defined a moment ago. And finally, I click Create to save the record set. Now I need to define another record for the secondary web server. I'll give it the same name and 15 seconds for the TTL. For the value, I'll copy the public IP of the second web server. So go back to the EC2 tab, copy that, paste it in here. And the routing policy is again failover, but this time the failover record type is secondary. And the record set does not need a health check associated with it because it's the backup. So I'll just go ahead and click Create. And so, okay, now there are 4 record sets in this hosted zone. The 2 A-type record sets are the ones I just defined. The first is the primary failover record set that has a health check associated with it, and the second is the secondary failover record set. So now let's test this configuration. I'll open a new browser tab and load the URL. And here we see that the primary web server, the one in EU West 2A, is the one that loads. That is as expected. And now we want to simulate an issue with the first web server. So I'll go over here to the EC2 page and stop the primary instance, which should cause the health check status to change. Let's return to the tab where I have the web page loaded and try refreshing the page. Notice the site is temporarily down. Now let's look at the status of the Route 53 health check to see if it's noticing. that there's an issue. If it does not already indicate an unhealthy status, give it a few seconds to notice that the website is no longer responding. Okay, it's been about 20 seconds, so now notice it is unhealthy. I'll load the page again, and there we go. The primary server is still down, but the website is responsive again. So as you can see, the failover routing is working. The website was only unresponsive for a few seconds. Specifically, it was unresponsive during the time it took for the health check to fail, given the health check interval of 10 seconds that I defined, and the number of consecutive health check failures that I defined as a threshold, which was 2. So after 10 times 2, 20 seconds, the failover routing rules kicked in, and the HTTP requests to my domain name are now being routed to the secondary instance that I specified. As a final step, I'll check my email and see if I received a notification. And yes, there it is. The email triggered by the health check and sent by the simple notification service informing me that one of my web servers did not pass the health check has arrived in my inbox. This concludes the failover routing part of this demo. In this third and final part of the Route 53 routing demo, I'll demonstrate how to configure geolocation routing. Geolocation routing lets you choose the resources that serve your traffic based on the geographic location of your users. In other words, the location that DNS queries originate from. In the routing solution I will demonstrate here, all users in Europe who load the Mom Pop Cafe website URL in their browser will be routed to the website instance running in the EU West 2 London region. And all users in North America who load the same Mom Pop Cafe website URL in their browser will be routed to the website instance running in the US East 1 Virginia region. This will allow us to localize the content. For example, the currency will display in British pounds on the London website and in US dollars on the Virginia site. So now that we understand the design, let's take a look at how this setup can be accomplished in the AWS Management Console. So here we are looking at the EC2 Management Console in the London data center, and you see that an instance of the Mom Pop Cafe server is running. Let's verify that the web server is working and the website is available. I'll copy the public IP address of the server instance and paste it into another browser tab. And I'll add Mom Pop Cafe to the end of the domain name since that is where the web app is running. And you can see that the web app is running. Notice on this page that it shows the availability zone of this server, indicating EU West 2A. That also obviously indicates the region, which is EU West 2, London. Now let's take a look at the Virginia region. Notice that there is also an instance of the Mom Pop Cafe server running here. Let's copy the public IP and verify the web server is running. It is. And this instance of the web server also displays the region. Now over here in Route 53, in the service dashboard, you can see that I have one registered domain and one hosted zone. If I click on registered domains, you can see that the domain named mompopcafe.net is registered with Route 53. And if I click into hosted zones and then click on the mompopcafe.net hosted zone, you see there are already 2 record sets that exist because they were created when the domain was registered. And as in the last demo, I'll leave the NS and SOA records alone. And now I'll need to create 2 new record sets, one for each region I want to route users towards. I'll click Create Record Set to start creating the first one. I give it the name www, and it'll be an A type record. And I'll make the time to live very short, 15 seconds. For the value, I need to grab the London web server's public IP address and paste that in there. So I go back to the EC2 page, showing the London resources, copy that, return to the Route 53 page and paste it in there. For the routing policy, I'll choose geolocation. Now here's where it gets interesting. I need to choose a geographic location. I can choose a continent or a country. For our purposes, I'll choose Europe. And for set ID, let's type in something descriptive like Europe-London, since we are routing all Europe traffic to an instance running in London. There is no health check to associate, so just click Create. And now I'll create the second record set. For the value, I need the Virginia web server's public IP address, and I'll paste that in there. And for the routing policy, again, geolocation. And the location, I'll choose North America. For set ID, let's type in something that matches the format we used before on the other record set. So I'll type North Amer-Virginia, and I click Create. Okay, so now there are 4 record sets in this hosted zone. The 2 A-type record sets are the ones I just defined. The first routes users in Europe to the London EC2 instance, and the second routes users in North America to the Virginia EC2 instance. Now let's test the configuration. For this demo, in order to emulate me being in different geographic locations, I've spun up 2 Windows instances. One is in California and the other one is in Paris. I'll first establish a remote desktop connection to the one in California. And now I'll open a web browser on this instance and pull up the mompopcafe.net site. And you see that I was routed to the Virginia instance, as we would expect. Let's look at the menu page and confirm the currency is in US dollars. And there you see it is. Now I'll establish a remote desktop connection to the one in Paris, France. Now that I'm connected, I'll open a web browser on this instance and pull up the mompopcafe.net site from here. And here you see I was routed to the London instance, again, as we would expect. Let's look at the menu page and confirm the currency is in British pounds. It is. Maybe I'm a resident of London, but I'm away on a short business trip to Paris, and I want to order some dessert that I can pick up when I get back in town. And there you have it. We have seen how the geolocation routing feature of Route 53 can be configured to route users to an instance in a specific region based on where on the globe the users are located. This concludes the geolocation routing part of this demo. Thanks for watching.
Hi, my name is Andy Katz. I'm here to introduce AWS Step Functions, a service from AWS that makes it easy to coordinate the components of distributed applications and microservices using visual workflows. Microservices are processes that communicate with each other over a network to complete a larger goal. Applications built as a collection of microservices are more resilient and easier to scale. A very simple microservice, even serverless in this case, can be deployed with an AWS Lambda function. And you can do a lot with just one Lambda function. Sometimes, however, your application requires more than one function. There are many combinations and patterns of 2 or 3 functions. For example, you may want a second function to always follow a first and only run if and when the first succeeds. You may want to execute 2 functions in parallel and feed the combined results into a third. Or maybe you would like to choose between 2 functions based on the output of a first function. You could write a lot of code to choreograph the interaction of your microservices, or you could use AWS Step Functions to coordinate your workflows. It's easy to get started with step functions. You declaratively define your workflows in the form of a state machine. Step Function visualizes your workflow, including tasks performed in sequence or in parallel, branching logic based on task results or other input, and timers. Step Functions manages each execution, keeping track of each step in a central audit trail, and managing task timeouts, retries, and error messages with built-in try, catch, finally patterns. Some examples of the kinds of repetitive processes that you can reliably automate with Step Functions include active synchronization of 2 Amazon S3 buckets, requesting a human approval by email and waiting till the authorized person responds before continuing with the workflow, image processing of photos, creating a thumbnail, and tagging image features using Amazon recognition in parallel. Step functions helps increase your productive time spent on business logic instead of plumbing, makes your applications more agile, and provides resilience